Alright guys, here we go. This is part 4 of chapter 2 in anatomy and physiology, and we're still talking about basic chemistry. So today we're going to talk about macromolecules and what those are. We talked about them a little bit, just kind of hit on it a little bit. We're going to get into some more detail here now. So first one of the macromolecules we're going to talk about is carbohydrates. Carbohydrates are extremely important for so many different body functions. They do so many things to help give us the ability to function on a daily basis and to have a lot of the processes of our body follow through. So carbohydrates are extremely important. Now, there are good carbohydrates and there are bad carbohydrates. Now, the good carbohydrates is what I'm talking about that we need, but the bad ones, not so much. But they're all made up of CHO, carbon, hydrogen, and oxygen, and they use a 1 to 2 to 1 ratio. So the most common one that we see is glucose, which is C6H12O6 if you wrote it out, and you see that a lot in biology and other science classes, because when you talk about photosynthesis and cellular respiration and stuff, it uses that glucose as an example. So there's 3 different types of classifications. Monosaccharides, which, if you remember terminology, mono means 1, disaccharide, di means 2, and poly, as you should remember, means many. So it means there's a lot of chains together creating a sugar. So sugars are carbohydrates. Monosaccharides are single sugar molecules. So like glucose is a single sugar molecule. That's a monosaccharide. Galactose is another. Fructose, ribose, deoxyribose. Those are all single sugar molecules, and they're called monosaccharides. They have about 3 to 7 carbon atoms in them, and these can join with each other to make disaccharides. So fructose and galactose, those are converted to glucose when they go into our cells. So we get fructose from a lot of the fruit that we eat. Bananas have a lot of fructose in them. Those are actually a really good source for energy, because when it goes into your body breaks it down and converts it to glucose, and glucose is what our cell uses to create ATP, which we've been talking about is energy, right? So and it needs that to go through cellular respiration in the mitochondria. Remember, the powerhouse of the cell, everybody likes to call it that. It gives us that energy, and glucose is a big part of that. These fructose and galactose are converted into that also when they go into our body. So disaccharides, you put a bunch of those, or a couple of those monosaccharides together, you end up with a double sugar molecule, which is called a disaccharide. And that happens through a reaction known as dehydration synthesis, which means you have to take a water away to allow that bond to occur. So glucose, fructose, glucose has an OH hanging off of it, and so does fructose. So you take that OH away from glucose and the hydrogen away from fructose, and that gives you water. When that water releases, now the glucose and the fructose can join with each other, and that creates sucrose, which we find in a lot of products that we eat. So, and you end up with that water. So that's a dehydration reaction to allow those two to come together, so it releases water. The double sugars are too large to pass through the cell membrane, so they have to be broken down to allow that to happen. So they go through a process of hydrolysis, which brings that water back in, and by bringing that water back in, it breaks them apart, and now you have 2 monosaccharides again. And that happens once it's inside the body, because you got to get that glucose and that fructose separated so you can use them in the cell, in the mitochondria, to go through cellular respiration and create energy. Polysaccharides, more than 2. So 3, 4, 5, whatever. You got a polysaccharide. And these are ideal for storage products. They're not really as sweet, but they're really thick and have a lot of good energy in them. Starches and glycogen, these are all polysaccharides that we get from like plants and potatoes and animal tissue and all those kind of things. So again, they're solid and they're multiple sugar molecules bound together, but once it goes in our body, it's got to be broken down into those simpler monosaccharides again, so we can use them in the glycolysis and Krebs cycle to produce energy. So we got monosaccharides, we got disaccharides, and we got polysaccharides. Using carbohydrates, I've been talking about this all along. Its main source is energy. So again, that mitochondria, it's the powerhouse of the cell, right? And so it gives us all our energy. What does it use to get all that energy? Carbohydrates. So carbohydrates are extremely important. There's so many diets and fads and stuff out there that are saying stay away from carbs, don't eat carbs, they're horrible, they're going to make you sick, they're going to make you fat. Carbohydrates are essential for body function. And so actually most of your diet should come from carbohydrates. About 55 to 60% should be carbohydrates. So taking away that macromolecule from your diet is detrimental to the overall function of your body because it affects the function all the way down to the cellular level because you don't have enough glucose to follow through a cellular respiration and you don't have the ATP that you need to create energy, and then you end up reducing your body's function. So that is exactly why people who go on low-carb diets are usually extremely irritable at the early stages of it because they're not getting enough energy and their body's kind of screaming for that energy. So how do we get energy from glucose? Glucose is oxidized. It comes in the body and it's broken down to carbon dioxide and water, and then it goes through that process of cellular respiration, which has multiple processes. First one is glycolysis, and then it's Krebs cycle, and then electron transport chain, and then it releases. You have multiple ATPs that are being released through that whole process. All right, so lipids is the second macromolecule, also known as fats. There's multiple different types of fats: neutral fats, which are also called triglycerides, phospholipids, which we have in our cell membranes. Those are important for cell membrane function, and so all the way down the cellular level, those fats are helping us. And then steroids also in our body are lipids. So we get them in meats and animal products, mostly animal products, but oils also. Oils are really one of the best sources of lipids in our diet because they're unsaturated fats, and that's the kind of fat you want. Saturated fats, not so good for you, but unsaturated, good stuff. So it's good fat. There is good fat. Not all fat is bad. We do need fat for function, and we do need enough to sustain our cellular membranes. And actually, fats are the second most valuable macromolecule that we need in our diet. We need about 35% of our diet to be fats, so we need a good amount of that as well. General structure of lipids: it's a large, diverse group of organic compounds, which is carbons and hydrogens, and then you have oxygen atoms also, and the carbons and hydrogens are the majority of that molecule. So typical fat this is tristerin, which is C57H110O6. So you can see that's a totally different combination than in carbohydrates. There's a lot more hydrogens and carbons than there are oxygens in a fat. Neutral fats, which is also called triglycerides. This is the type of formation they take. So you got a glycerol group on the outside, and then you got 3 fatty acids. And so this is an example of a triglyceride, saturated triglyceride. So those are neutral fats. Saturated and unsaturated. If each carbon of the atom in a lipid's fatty acid chain is joined to another carbon, then that's considered saturated. It means that there's no way for anything else to get in there, no way for anything to react with it. Unsaturated is at least one of those carbons is a double bond or a triple bond in a fatty acid. So that's unsaturated fat. Oils, like I said, is a good example of unsaturated fats, nuts and those kind of things. But these are the kinds that we want because these are the ones that we can break down easier and we can use as energy a lot easier. Saturated fats are a lot harder to break down, so they kind of build up in our system a lot more. Unsaturated fats we can break down easier. Oleic acid is a mono unsaturated fatty acid, so you can see this double bond here. That says that it's unsaturated. This one here, you see they're all connected. That's a saturated fat. This is an unsaturated fat over here also, linoleic acid. So what are the functions? Fats are a great source of energy. They give us 9 calories for every gram of fat that we eat. So it's actually a really good source of energy, better than carbohydrates and proteins, which only give us 4. So they give us sustained energy too. So if you're going to want to have energy for a long time, you want to eat fats the night before whatever you're going to pursue that requires a lot of energy. But again, you want unsaturated fats, not saturated fats, because you'll break them down easier and you'll hold them in your system. They also help insulate our body and they protect the deeper organs in our body. Phospholipids, glycerol molecule plus 2 fatty acids in a phosphorus-containing group. Like I said earlier, these are what our cells use to make cell membranes. So they have a phosphorus in them, and they come together to give it certain chemical properties and polarity. We talked about polarity before, how it kind of changes the structure of things. And so it allows for a really solid structure so that it can create a membrane around our cells. So here's a formation of triglyceride. We talked about this before, the glycerol group and the 3 fatty acids. The phospholipid is different. You got a phosphorus-containing group and then a glycerol and 2 fatty acid chains. Steroids are the last one. It's basically a flat molecule. You got 4 interlocking rings, so 1, 2, 3, 4 here. Cholesterol is an example of a steroid. And cholesterol comes from animal products. We naturally create cholesterol in our body too through the liver. But when we eat more animal products and the types of things that have cholesterol in them, it can increase our cholesterol. There is good cholesterol, high density lipoproteins, HDLs, but there is bad cholesterol also, LDL. So you want to have a high HDL and a low LDL to have healthy body. So here's what cholesterol looks like. Those 4 groups laying flat together, interlocked. And then saturated fats, I mentioned earlier, saturated fats and cholesterol have been implicated as substances that encourage atherosclerosis, which is definitely true. And what atherosclerosis is buildup of plaque in your vessels. So you don't want to get too much of this. Again, you can have a little bit, but you don't want to have too much. Less than 10 to 15% of your fat should be saturated fats, because you don't want to allow this atherosclerosis to occur because it can block the blood flow in your body. You want to have more oils and nuts to prevent that. And this is Macromolecules to start.